Today we're taking a look at some sample problems from section 1-4. Again, some of these are discussion problems, so I'll simply talk about them. In others, there may be short answers, which I'll jot down when we get to the problem. So we'll begin with number 2. It says, want to conduct a study to determine whether fruit consumption leads to reduced weight. Why would an experiment be better than an observational study? If you do an observational study, you do not have as much control over the different variables. So someone who eats a lot of fruit may or may not have good eating habits otherwise. And so it's hard to control that. So it would be much better to do an experiment where you would have a control group that would not eat the fruit and then a group that would eat the fruit to see which group actually lost more weight. So it would be better to do an experiment here simply because you wouldn't have any lurking variables that might influence your results. Not as much of a chance of lurking variables. All right, a convenience sample. The author conducted a survey of the students in all of his classes. He asked the students to indicate whether they are left-handed or right-handed. In this convenience sample, is this convenience sample likely to produce results that are typical of the population? Are the results likely to be good or bad? Does the quality of the results in this survey reflect the quality of convenience samples in general? Because of the fact that he's surveying students in his class and there would be no reason for more right-handed or more left-handed students to be in this class of his, the convenience sample certainly would be an acceptable way to sample the class and to draw conclusions about the general population. However, in general, convenience samples tend to be bad, and that would be if you're looking at opinions and you're trying to survey someone like your family members or your friends, you're more likely to get someone who has thoughts and ideas close to yours, and you're not likely to get the thoughts of the general population. So in general, convenience samples tend to be bad. You need to think carefully before using them. If it's done in such a way that you feel like it's not affecting your outcome, then sometimes the convenience sample will work. Okay, now we're going to the next group where we're deciding whether we have an observational study or an experiment, and we want to explain why we chose it. So in number 6, we have a clinical trial. We have a clinical trial of Lipitor. 188 subjects were given 20 milligram doses of the drug, and 3.7% of them experienced nausea. So in this case, because we are giving a treatment, it would be an experiment. And that's the reason, simply because we are giving a treatment. In number 8, the happiness survey in a study sponsored by Coca-Cola. 12,500 people were asked what contributes most to their happiness. 77% of them said it was their family or partner. So in this one, we're not providing a treatment, we're just observing. So it would be an observational study as opposed to an experiment. So basically you're looking, was there a treatment or was there not? If there's a treatment, it's an experiment. If not, it's an observational study. Okay, in number 10, we're asked from 10 to 20, we're looking at the types of sampling: random, systematic, convenient, stratified, or cluster. So in number 10, the sexuality of women was discussed in Sherhite's book, Women in Love, A Cultural Revolution. Her conclusions were based on sample data that consisted of 4,500 mailed responses from 10,000 questionnaires that were sent to women. So notice we're not asked whether this is a voluntary response sample, which it is. So the question is, how do we identify it? Is it random? No, it's not random. Is it systematic? No, it's not systematic. Is it stratified? No, it's not stratified. Is it cluster? No, it's not cluster. So that only leaves convenience. It was convenient for her to mail out the questionnaires and then to use the data from the ones that were returned. Let's make it convenient since that's what they're asking. Okay, ecology in number 12. When collecting data from different sample locations in a lake, a researcher uses the lined transect method by stretching a rope across the lake and collecting samples at every interval of 5 meters. Okay, so every 5 meters. So it's like, you know, every 5 meters, every nth item, that would be systematic. Okay, 14, acupuncture. We have in a study of treatments for back pain, 641 subjects were randomly assigned to 4 different treatment groups of individualized acupuncture, standardized acupuncture, simulated acupuncture, and usual care. So, what is the key? Okay, as we look at the possibilities, thinking about the possibilities, it's not systematic, it's not convenience, it's not cluster. So we're down to random and stratified. Okay, and they're randomly assigned to 4 different treatment groups: individualized, standardized, simulated, and usual care. So, stratified, if we think about this, it's 4 different groups, but there's not anything common. Like, they're not all of the same gender, they're not all of the same age, they're not. So if we eliminate stratified, and because of the word randomly, it turns out to be random. Can't spell here. Let me fix. So random. Alright, so that's, you're kind of seeing my thought processes as I go through these. Okay, 16. The author collected sample data by randomly selecting 20 different pages from a printed version of the Merriam-Webster dictionary and counting the number of fine words on each of those pages. Okay, so alright, so the author collected sample by randomly selecting 20 pages. Okay, so the dictionary is divided into pages, and the individual is selecting 20 different pages. So that's like 20 different clusters, and what they are doing is they're counting all the words on those pages. So it looks like cluster. Let's see if we can look at the others and eliminate them. Alright, random might possibly be. It's certainly not systematic. He's not selecting a starting spot and then going every nth page. It's not convenience. It's not stratified. So that leaves us with cluster and random. And because of the fact that like I said, each page acts like a cluster. It's a cluster of words. I would go with cluster on this one. Okay, and let's take a look at our next question. and my battery's going low, so let me plug in here. Hang on a minute. Okay. Now, let's look at number 18. On the day of the last presidential election, ABC News organized an exit poll in which specific polling stations were randomly selected and all voters were surveyed as they left the precincts. So again, that looks like a cluster. They're serving everybody from the randomly selected precincts. Okay, in 20, the New York State Department of Transportation evaluated the quality of the New York State Thruway by testing core samples collected at regular intervals of 1 mile. So regular intervals, that's going to be systematic. Okay, and 22, in order to test for gender gap in the way that men and women purchase cars, the Grant Survey Company polled exactly 750 adult men and 750 adult women randomly selected from adults in the United States. And our question is, determine whether the sample is a simple random sample and give a brief explanation of your choice. Alright, so our sample totals to 1,500 men and women. Because of the fact the sample size is 1,500, there is no way to get 1,500 men or 1,500 women or even 700 men and 800 women or 1,000 men and 500 women. Because none of those are possible, that means all samples of size 1,500 are not possible. So that means it's not simple random. So that's a little bit tricky. You have to look at the entire sample. There's 1,500 people in the sample. So you think about, is it possible to get every sample of size 1,500 in selecting these men and women? And the way they selected it, because they selected 750 of each, we have no possibility of getting any samples other than 750 men and 750 women. We can't get all men or all women. We can't get 1,000 men and 500 women. So that's what makes it not simple random. Okay, and our very last one, 24, according to the state of New York Unified Court System, names of potential jurors are selected from a variety of different sources. When a trial requires a jury, names from the list randomly selected in a way that is equivalent to writing the names on a slip of paper, mixing them in a bowl, and then selecting the required number of potential jurors. So this would be a simple random sample. If you're talking about a jury of 12, all groups of 12 are possible. All of the sample size 12 are possible by this method of selection.